Today, on how it's made. Carbon fiber bicycles. Blood products. Forged chandeliers. And ballpoint pens. Carbon fibers are minute hairs of almost pure carbon. They may be tiny, but they're 3 times stronger and 4 times lighter than steel. Weaving them together and bonding them with plastic resin, then molding this material into a bike frame, creates one lean, mean pedaling machine. This company builds custom-made carbon fiber bicycles for professional athletes and serious amateurs. The first step is to take detailed measurements: height, weight, and limb length, as well as shoulder width for handlebar spacing, inseam for the seat placement, and even shoe size for positioning the pedals relative to the front wheel. Computer software translates these data into a geometric diagram of a customized bike frame. A cutting machine slices out carbon fiber shapes that will become the frame components. The bicycle frame is made up of 9 parts. They make each one with an aluminum mold and a latex balloon called a bladder. They wrap the bladder with a layer of carbon fiber. The fibers in the material all run in one direction, so to add strength, they apply several layers in a specific crisscross pattern. After coating the mold cavity with a release agent to prevent sticking, they place the wrapped bladder inside, then install an inflation cap. They place the mold in a specialized heat press, hook up pressurized gas, then insert a temperature and pressure monitor. The inflated bladder forces the carbon fiber to take the shape of the mold cavity. After about 20 minutes, they extract the molded part, then begin the refining process. First, they sand off any release agent residue. Then they machine the part to exact specifications for a precision fit with its connecting parts. Following the geometric diagram, they assemble the bicycle frame like a puzzle. Once they're sure everything fits together properly, they disassemble the pieces, then coat the connectors with super strong aerospace adhesive. They reassemble the parts, then cure the glue in an oven for about half an hour. The bicycle frame now goes onto an inspection table. A technician uses digital measuring equipment to ensure the alignment is perfect. The next step is to install test wheels and check that they rotate perfectly straight. Back to the frame. They remove any excess glue that oozed out when they slid the part together and give the frame an overall sanding. The surface must be perfectly smooth before they can paint it. They do all the painting by hand with spray guns. First, they coat the frame in a primer and sealer. Then they use a series of adhesive stencils to apply the paint colors one at a time. They spray on a coat of clear automotive lacquer. This protects the paint against UV light and chipping. Next, using this tap, they remove paint that dried inside the threads at the base of the frame, where the gear mechanisms screw on. They repeat this procedure at the head of the frame, where the handlebars attach. Now, it's just a matter of installing the specific components that the customer ordered. The carbon fiber frame delivers maximum strength and stiffness with minimal weight. It's the key to the bicycle's high-end performance. The average person has 5 liters of blood running through their veins. Out of this blood come 3 products that can save lives: red blood cells that carry oxygen, platelets that help stop bleeding, and plasma, a protein-rich liquid that helps us fight infection. Hospitals need all blood types to help them save lives. One day, your life could depend on donated blood. In this setup, an automated machine collects the donor's blood and separates it according to which blood product they need. The collection machine draws whole blood from a donor's arm and separates out the mixed plasma and platelets, which is the color of straw. In every setup, some blood is diverted into a pouch for testing. In this method, they're collecting whole blood that will be separated at the lab. A worker then draws blood from the pouch for testing at the lab. Meanwhile, the machine mixes the whole blood with an anticoagulant so it won't clot in the bag. The donor's blood samples then go to the lab, where they determine the blood type and test for infectious diseases. This high-volume, high-quality blood testing machine is unique to the blood banking world. Fully automated, it helps ensure the safety of the blood supply by testing donor samples for things like hepatitis B, C, and HIV. In 8 hours, it runs 5 different blood tests on 1,000 donations without human intervention. Between each of these tests, it sterilizes every single probe in a wash solution. Another machine determines the blood type, of which there are 8. They scan the donor's collection bag and document what products they will produce from the blood. Then they weigh it. Overnight, gravity causes the blood to separate into its 3 components, so a worker remixes it, preparing it for machine separation. She then packs the blood and the bags for the other components into what's called a liner. She makes sure the liners are balanced and will put a rubber weight inside when she needs to. Balancing the liners keeps the centrifuge machine spinning properly at 4,000 RPM as it separates the blood into layers. She then hooks up the unit of separated blood to an automated extractor and once again matches the unit with the donor. The extractor fills a bag with just red blood cells. As the machine fills the bag, it leaves behind a mixture of blood and platelets in the original container. As it extracts these red blood cells and leaves behind a portion of blood and platelets, it also fills another container with pure plasma. An incubator keeps the processed platelets well mixed. They only have 5 days to use these platelets. However, they freeze plasma and can use it for 12 months. Finally, they filter out the white blood cells from the red blood cells using what's called a leukoreduction filter. They also introduce an additive solution into the red blood cells and mix it all together. The additive helps the red blood cells survive for 42 days, both inside a fridge and during transportation to the hospitals. Today, most forged chandeliers are wired for electricity. We've replaced the candles used in earlier times with decorative bulbs and lampshades. But a forged chandelier still relies on traditional blacksmithing techniques and the hand assembly of components used in modern lighting fixtures. To build this two-tiered chandelier, the artisan begins by making the twist basket shape. First, he cuts lengths of steel bar with this shearing machine. He arranges 6 of those bars in a bundle, held firmly together by this welding fixture. He welds the bars together, leaving a hole in the center through which the wires will pass. A worker puts the bundle into a forge that softens the steel at about 1000 degrees Celsius. She then mounts the softened bundle in a twisting machine, securing it tightly in place. She turns the wheel, spiraling the bars together. Then she reverses the wheel, causing the center of the bundle to pop out, creating the twist basket design. She makes sure the shape is symmetrical. Then she verifies its length in a gauge. Next, they clean the basket with tiny steel beads in a process called bead blasting. Here, they make the J-shaped arms used for the upper tier of the chandelier from metal tubing, which they shape in this rotary bending machine. With the same machine, they also make the S-shaped arms used for the lower tier of the chandelier. All the arms are hollow, which will allow wires to pass through them. A vibrating ceramic medium then polishes all the components that make up the chandelier to give them a smooth finish. Using a mounting fixture, a worker places the polished upper arms in what's called a distributor. He welds the arms to the distributor, which both supports them and gives them the proper alignment. He welds the lower arms to another distributor. Next, he welds metal tubing onto each end of the twist basket. This tubing makes it possible to connect all the decorative components. A worker then attaches those decorative components, which include a loop to hang the chandelier and an end cap that attaches to the distributor. She completes what is called the center core by tightening everything in place. Then they spray the upper and the lower arms as well as the center cores with powder coating, a finely ground plastic about the consistency of talcum powder. The center cores and arms then go into an oven, where heat cures and bonds the powder coating, giving the parts a hard finish. A worker then connects the upper and lower tiers by fitting the distributors together. This hides the wiring connections. He secures the center core to the distributors using a decorative finial ball. He then puts candle sleeves on to hide the light bulb sockets and wires. The twist basket chandelier is now ready to brighten your day. Forged chandeliers help establish the mood of a room. They come in various styles, from classic to ultra-modern, and their designs are limited only by the artist's imagination. In a world where inexpensive, disposable ballpoint pens are the norm, there are still discriminating people who prefer using a deluxe writing instrument. A fancy, high-quality ballpoint pen is as stylish as it is functional. It's often paired with a matching pencil in an elegant gift set. Silver-plated, alligator leather, chainmail, rose gold with crystals. Pen casing designs are endless. This model is decorated with lacquer, made from the resin of a particular tree that grows only in China. They apply it using a special brush made of human hair. Coating the recessed areas of a brass pen casing creates the effect of black stripes running the length of the pen. Once the resin dries, they wash the pens several times. Then, with a cotton wheel and some polishing compound, they buff the lacquer to a high-gloss shine. Here's another model with an etch design. A computer-guided machine engraves the fine, intricate pattern with a diamond chisel. The casing is brass, but they'll plate it in a precious metal such as gold, platinum, or rhodium. Every pen, regardless of design, has a brass or sheet steel clip that coordinates with the rest of the pen. They position the clip on a press, and it applies just enough pressure to push tiny pegs into holes in the cap. The factory tests every clip for tension resistance. It has to stretch to a certain extent, then return to its original shape. The pen's tip is made of brass plated in silver, gold, or rhodium. This machine drills the hole through which the retractable ballpoint will protrude. This machine injects ink inside the pen cartridges, which are made of brass. It then caps the writing end with a tip containing a tiny stainless steel ball. As the pen writes, the ball transfers ink to the paper. The machine then flips the cartridges in the opposite direction and shoots some grease through the other end. This seals the ink inside. Now, the filled cartridges go for a ride on a centrifuge machine, which pushes the ink down toward the ballpoint. This machine runs random samples through a quality control test for ink flow, ensuring each cartridge outputs 8 kilometers of quality writing. A twist mechanism at the top extends and retracts the cartridge writing tip through the pen tip. The factory tests the mechanism on each and every model thousands of times. Now onto another model, this one decorated in chainmail. Workers cut the material to pen length, then fasten it around the brass pen casing. After several washes in water and solvent-free detergent, followed by several rinses, they precision glue the tip and cap to the casing. Then they insert the cartridge, along with a spring to provide resistance when the ballpoint presses against the paper. Finally, they cap the top with either a push-button mechanism like this one or a twist mechanism, as we saw before. Before packaging, every single pen undergoes one last quality control check under magnification to be absolutely certain that even if your spelling is poor, your writing will be great.